Okay, so hopefully this is recording because I only get one shot at it. Obviously, Health Academy, you can pause this if you need to, or have Mr. Nguyen pause it, or whatever. I'm going to be speaking fast because class is supposed to start in 22 minutes, and I need to get this sucker done. So, dealing with connective tissues, which is one of the 4 classes of tissues, what we're going to try and figure out is how the structure tells you about its function. Straightforward. So the thing to remember is that tissues are actually collections of cells, and this one I never told you about, but basically what you have is this phenomenon referred to as an emergent property. Meaning, if I were to take a bunch of atoms right here on the left side, and if I combine them in particular ways, you make molecules. Molecules are capable of doing things atoms cannot do. If I take molecules and stick them into a particular arrangement, you can create a cell. Cells do things that molecules cannot do themselves, because cells are alive and molecules aren't. So every time we kind of combine things together, you get more stuff happening than you could with the parts themselves. When you start talking about tissues, it's the exact same phenomenon. We get bunches of cells that do certain things, but when collected together, you get something new occurring with these tissues. With the epithelial tissues, and this is a really complicated looking figure that came out of it's a very prestigious science journal called Nature. Basically, when you look at this figure, what you notice is down here at the bottom, there are things called stem cells. Stem cells are there to replenish cells that fall apart. Epithelial tissues fall apart because they're always on surfaces. So we need to have a way to replace them, and that would be a stem cell. Stem cells are always dividing, so we are always using our stem cells. It's why if you are going to get a cancer, you have a good shot at getting it at an epithelial tissue because we have cells there that are always dividing. Which is why in Henrietta Lacks, her cancer came from an epithelial tissue. That's where she got hers from, because we have cells that are always dividing. Connective tissues, not as common because they're not necessarily always dividing. Yeah, this was an easy slide. If I look at connective tissues, they are composed of 3 parts, what I call the cells, gels, and fibers. The cell is usually going to be called a fibroblast, right here, this funky looking thing down here. There are other versions of it, but for the most part we call them fibroblasts. They're going to make some type of protein that are excreted from the cell, and those are going to be what I call the fibers. For the most part, they're going to be things like collagen, which is among the more common ones. There are a few others like reticular fibers and elastic fibers or elastins. And then they're going to promote, by secreting chemicals, some type of background around them that I call the gel or the matrix. So it's all the junk around the fibroblast within this particular tissue. And the gel can be either really runny or it can be insanely hard, and it's going to be somewhere in between. And all connective tissues have these 3 things: cells, gels, and fibers. And the question just becomes, what do you happen to have more of? Do you have more cells? Do you have more gels? Do you have more fibers? What's the composition of the gels? What's the composition of the fibers? All of the connective tissues we put into 3 categories, and this is the best picture I could find, which is not a particularly good picture. But basically what you can have are, we put them into clumps. So one of them we call the proper connective tissues, like here where it has fibrous and loose. And adipose. We have what we call the structural ones, which are cartilage and bone. You build stuff out of them. Then we have the liquidy ones, like blood. And there's another one called lymph. So for the proper connective tissues, they're either what we call dense or loose, and it all depends on how closely you pack all the junk together. So these 3 here are what we call the loose proper connective tissues. So this one here called areolar means airy and light. This is the stuff that's kind of like the glue that fills in everything, and it's really hard to find it. This is the stuff, areolar tissue is the stuff that exists if you got rid of everything else. So if you could delete all of your body, all the normal cells, all the normal proteins, all that stuff, and just leave the connective glue behind, this is what you get, is areolar tissue. You have it everywhere. And it's really hard to find, but when you see it, meaning if you were hunting for it on your own, you had to make your own slide, good luck. But we have slides that already have gone through all that nastiness, and then it's really easy to find. Adipose is just a bunch of fat. Adipose means fat. So fat cells turn out to be a loose connective tissue because you can wiggle and jiggle with it. Then there's this one here called reticular, which involves these proteins called reticular fibers. These things, basically, you can think of as big batches of loose cotton or of wet cotton. So if you can think of cotton, that's what reticular tissue is. Adipose is butter, and areolar tissue is glue. The other ones are the dense ones. So we call them dense regular, dense irregular, and elastic. Dense regular, it's called dense regular because there's a pattern to them. Dense irregular has no pattern to it. A lot of you, when you were looking at the skin or you're trying to find your stratified squamous epithelium, you're looking actually at dense irregular connective tissue. What these things do is they resist being pulled apart because they can have lines of force. You can tug on dense regular connective tissue up and down, in this picture, up and down, and they won't tear. If you rip them side to side, we're going to have an issue. But dense irregular, whatever direction you pull, they're not going to fall apart. So it's actually a pretty good battle plan. The elastic tissues, these are meant to be able to be elastic, meaning you can stretch them and they go back to your shape. We'll play around with that later, but basically you could test it on your hands, and I'll tell you about the age test that you can do with that. The structural ones fall under two categories of what we call either cartilage or bone. I don't have a picture of bone here, but we'll deal with bone enough. Cartilage is bone that isn't as hard. And there's actually three major groupings of these things. One's called hyaline cartilage, that would be like your nose. There's one that we call elastic cartilage, which would be your ears. And then we have this stuff called fibrocartilage, which is not easy to find. You have little bits and remnants of it inside of your back. Basically, it's there to make a shape, but it's harder to break. The fluid ones look almost identical, and it's blood or lymph. Lymph is a special type of fluid that we will spend quite a bit of time on, so I'm not going to really describe it here. But here, the gel is really liquidy. In the structural ones, the gel is pretty solid. And for the proper ones, you're somewhere in between. If you take connective tissue and epithelial tissue, you can combine them to make a structure called a membrane. This is not like a cell membrane, it's a totally different type of membrane. These membranes turn out to have combinations, like I said, of epithelium and connective tissue. When you look at epithelial tissue, you actually have a bottom and you have a top. So they are polar. Hopefully you can see this mouse kind of moving around. So the top of epithelial tissue, there's a top and you can tell where the top is. And there's a bottom and you can tell where the bottom is. The catch is you need to glue the bottom somewhere. And that is collectively what we call the basement membrane. So we attach epithelium with some glue called a basement membrane. That basement membrane is then connected to connective tissue underneath. All of this, meaning the epithelium, this attachment point, the basement membrane, and the connective tissue is what we call a membrane, a structural membrane, not a cellular membrane. There turn out to be 4 of these types all throughout your body. The one that you know the best is what we call a cutaneous membrane, because cutaneous means your skin. It's a dry membrane, so that would be you touching your skin. You're looking at it all the time. The other type, just going in order here that they have on the left for the sake of saying it, a serous membrane, well, the rest of these are all going to be wet. A serous membrane is be one in which you happen to allow movement or gliding past each other, but it's movement or gliding simply because of the fact that you don't want organs to rub into each other. So on this picture, the serous membrane actually turns out to be this one, number 2, because we don't want the edge of your abdomen rubbing against your colon, because if you do, there's going to be an abrasion, you're going to get an inflammation, and issues then result. So by having a serous membrane, you have a thin layer of fluid that allows your wall of your abdomen and the lining of your intestines to slide past each other and not get stuck. A synovial membrane does the exact same thing, except it happens at joints. So if you've ever known people who've blown out their knees or they need a knee replacement, that's because the person's lost his or her synovial membranes. They've been destroyed. Mr. Burns has a fake hip. The reason why he has a fake hip is his hip synovial membranes have been destroyed. So we put in an artificial one. But again, they're just there for gliding. All of these are wet, and serous and synovial, the S's, are for gliding. Mucous membranes have, shockingly enough, mucus in them, which would be number one. The giveaway would be it says mucus up there. So it's what this turns out to do is it's a protective layer, and it's for absorption. So whenever you are told for bloodborne pathogens, like you need to worry about guarding your mucous membranes, that's because stuff can get into your body through a mucous membrane. They don't get through cutaneous membranes or serous membranes or synovial membranes. But mucous membranes, any place that's wet, inside of a lining, you have that. So where would that be? Like the corner of your eyes or in your mouth or up your nose or along your alimentary canal, which is your digestive tract. All of those places turn out to have mucous membranes. Just for the sake of saying it, mucus, when it has an OUS, that means a membrane. Mucus without the O, so MUCUS, that's like the stuff you shoot out of your nose or you cough up. So spelling does count. That was a very fast version of all of this. I'm sure it was stopped a few times. If not, you should have asked for it to be stopped a few times. So good luck today.